Today we're solving inequalities using addition and subtraction, and we're going to look at two key properties that help us solve inequalities using addition and subtraction. First, we're going to investigate the addition property of inequality. This property states that when you add the same number to each side of an inequality, the inequality remains true. So if I have an inequality like x minus 5 is less than negative 3, I can isolate my variable, get x by itself, by adding 5 to each side, because minus 5 and plus 5 cancel out and I'm left with x. I need to also, though, add that 5 to my other side, so negative 3 plus 5 is 2. So the solution set for this inequality is x can be anything less than 2. The subtraction property of inequality states that when you subtract the same number from each side of an inequality, the inequality remains true. So here I have 13 is less than or equal to x plus 14. To get x by itself, to isolate my variable, I will subtract 14 from each side to keep everything balanced. I'll have x on this side, and 13 minus 14 leaves me with negative 1. So the solution set for this inequality is the value x can be anything that is greater than or equal to negative 1. So let's solve some inequalities using addition and graph their solution sets. So here I have the inequality y minus 3.8 is less than or equal to 1.7. So to isolate y, I'll add 3.8 to each side, which leaves me with y by itself is less than or equal to 5.5. This value came from taking my 1.7 and adding the 3.8. So now I know that my solution set is y can be anything less than or equal to 5.5. Since it can be equal to 5.5, I'm going to put a closed circle at 5.5. On a number line, all the numbers to the right are getting larger and numbers to the left are getting smaller. Since y can be anything that's less than 5.5, I'm going to highlight all the numbers to the left, including the arrow, because I have solutions that will go on infinitely. Let's look at another example. Here I have negative 1/2 is greater than z minus 1/4. So in order to solve for z, I'm going to add 1/4 to each side. On this side, minus 1/4 and plus 1/4 will cancel out and I'm left with z. On this side, negative 1/2 plus 1/4 will leave me with negative 1/4. So on my number line, I want to make sure I have negative 1/4. And I'm going to put a few things that are larger than negative 1/4 to the right and a few things that are smaller to the left. I'm going to use an open circle at negative 1/4 because I don't see an equals part on my inequality sign, so z can't actually be equal to negative 1/4. It must be something that is smaller than or less than negative 1/4. So I'm going to highlight everything going to the left here, including my arrow, because I have answers that will go on infinitely to the left. Now I'm going to try solving some inequalities using subtraction. So here I started with w plus 7.5 is less than or equal to 5. To isolate w, I will subtract 7.5, but I need to do it to both sides to keep everything fair and balanced. So 5 minus 7.5 leaves me with negative 2.5. So w is less than or equal to negative 2.5. So I filled in my circle because it can't actually be equal to negative 2.5. or anything smaller. So anything to the left should be highlighted, including the arrow. Here I have x plus 3/4 is greater than 1.5. So to isolate my x, I'm going to take away 3/4 from both sides. This is going to leave me with x over here and positive 3/4 on the right. So I definitely want to have 3/4 on my number line. And I'm going to include a few things that are larger than 3/4 and a few things that are smaller than 3/4. I'm going to use an open circle at 3/4 because I do not have an equals here. It can't be equal to 3/4. But x is going to be anything that's bigger than 3/4. So anything going this direction off to the right. And I will also highlight my arrow because the answers go on infinitely to the right. So let's look at a word problem here. A person can be no taller than 6.25 feet to become an astronaut pilot for NASA. Your friend is 5 feet 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So first of all, I noticed that this height is given in decimal form, and this one is given in feet and inches. So let's convert this one to a decimal. So if someone is 5 feet and 9 inches tall, they're 5 9/12 of a foot, because there are 12 inches that make up 1 full foot. So since they're 9 inches, they're only 9/12 of that last foot. This can reduce to 5 3/4 of a foot. And 3/4 can be changed into 0.75. So your friend is actually 5.75 feet. I'm going to use that measurement when I'm writing my inequality. So my friend is 5.75 feet, and we know he can grow a little bit, but we're not sure quite how much. So 5.75 plus, we'll call that amount he has to grow X, but he can't get greater than 6.25. He can be equal to 6.25, but he can't go over that. Otherwise, he can't be a pilot. He won't fit in the NASA shuttles. Therefore, this is the maximum height he can be in order to be that NASA pilot. So now let's solve this. So we'll subtract 5.75 from each side. Here I'm left with X. And on this side, if I subtract these, I'm left with 0.5. So your friend can grow anything less than or equal to 0.5 feet and still be a NASA pilot.